This is the weirdest interaction with what you movie? He's like watching movies too. I don't know. She'd be like, why don't you bully this dude? So I'm sitting on the staircase and I just watch this and the rest of the day. And I'm like, well, I can't. He's like, I love to wrestle. He's like, start the UFC fight or whatever. I was like, yeah, you do. Ooh, I gotta send you one.
Hey, wait, that's what
We already did all that. Oh, yeah.
Okay, during the minute of silence, y'all need to make sure that you turned in 67 in the Google Classroom. I'm going to be checking those in a couple minutes, and after that it'll be late, so if you're not sure if you turned it in, do that during the minute of silence, please. I'd asked you to do it last class, so you probably already have it done, but...
I wasn't here yesterday, so I missed that retake.
Yeah, I can't change your prime time schedule during the week, so I don't know. You can email Richard Campbell if there's a day that you're put in somewhere that you don't really have to be, and I'm fine if you come in some other prime time day. Other than that, as soon as I can put you back in is next Tuesday. Okay, I guess there's no minute of silence today, so while you guys make sure that you've done that, our two handouts today could not fit on one piece of paper, so the notes part is going to be 72. Or no, I'm sorry. Both of those make up 72. I'm sorry. The 2 pages you picked up both make up 72. Number on both.
Good morning, Fable High School.
maybe
Today
staple
is
on there.
Wednesday, January 31st, 2024. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and have a great day.
All right. So today we're going to do kind of like we've done the last few classes, where we're going to add a little bit new information to the limits part and ask you to practice a little bit of something you've practiced before. So the new part today is we're going to talk about indeterminate form with complex fractions. So we did indeterminate form with factoring on day 1, or two classes ago we did dealt with indeterminate form with factoring. Last class we dealt with indeterminate form with conjugates and trig identities. Those were the 2 new things that we practiced. And then today we're adding how to deal with 0 over 0 with complex fractions, which again, is about 95% algebra work, so it's a good review for complex fractions anyway, because complex fractions show up in math all over the place. And we'll do some limits from piecewise functions, which is mostly just practicing from piecewise functions. Then I suggest you look over the two handouts from last class, which would be 69 and 70, because the practice I'd like you to get from previous class is, I picked out one Khan Academy for you. Only one this time, because it's the conjugate type of questions we did last time. And you know those take a couple minutes each, so. Okay, so the stuff that you've heard for days now, so hopefully this is getting cemented in your brain here, but you should always start off with direct substitution. And if you get a real number, that's your answer and you can quit. Try not to overcomplicate it. There was one question on our notes last time that I didn't think to do that, and then I had to erase a couple minutes of work. With direct substitution, if you get a number other than 0 divided by 0, that fraction is undefined, which means that the limit does not exist. Again, basically the same first two questions that we've talked about for days, just to keep reiterating that, because that still carries on to today. Okay, but what is a little bit different about today is when we do direct substitution, looks like my numerator goes to 0, my denominator goes to 0, so this is still what we call indeterminate form. By the way, there's more indeterminate forms other than 0 over 0, but that's the only one you need to worry about at this point. Some indeterminate forms you wouldn't ever learn until you do like Cal 3 or advanced calculus or something like that. But the process of dealing with this 0 over 0 is going to be different than we've done the last couple of days, because it doesn't factor like day 1. There's no square roots in here to do conjugates like last class, and there's no trig functions in here to deal with this like last class. So our purpose is still the same. We need to make this look different, get something to cancel, and then retry direct substitution. But in this case, the algebra is you have to remember how to simplify a complex fraction. A complex fraction is when you have these smaller fractions within a bigger fraction. So the first thing you want to do is to fix that. You want to make it so that it's not a complex fraction. So what I'd really love to do is multiply this by 3, because times 3 divided by 3 cancels out. That's what I want to do. But if that's all that I do, then I'm basically just pretending like this is a -1 and not a -1/3. So to keep it mathematically balanced, I basically have to multiply the top and the bottom of this fraction by 3 and then distribute it in the numerator. So basically, if you want to multiply one fraction by 3, every term has to be multiplied by 3. And again, it's like I'm multiplying the top and the bottom of my fraction by 3, and that 3 is being distributed in the numerator. Of course, multiplying by 3 over 3 is like multiplying by 1, which doesn't change the size. Okay, along the same logic, I need this small fraction to go away. So I would love to multiply it by x plus 1, but I have changed the question unless I multiply every term by x plus 1. Once again, it's like multiplying the top and the bottom by x plus 1, so it's like multiplying by 1, it's just in the numerator is getting distributed. So complex fractions get kind of, again, there's probably a dozen different times if you guys pursue a math or science career that you're going to have to deal with complex fractions anyway. So, but it gets kind of messy, but when the smoke clears here, we've got 3 times 1, we've got a negative x plus 1, so make sure you distribute the negative. And in the denominator, we had the x minus 2 that was there the whole time, the 3 that we multiplied it by, and the x plus 1 that we multiplied it by. Now we might still have 3 or 4 more steps in this question, but you need to appreciate that we went from a complex fraction to a not complex fraction. I had smaller fractions within my bigger fraction, and multiplying everything by 3 and multiplying everything by x plus 1, bless you. Now at least I don't have a complex fraction. So So to finish this one, I could combine like terms here. 3 minus 1 is like 2. Similar to day 2 where we did factoring, similar to day 3 when we did conjugates and trig identities, you need something to cancel before direct substitution is going to work again. So this one and this one are almost the same thing, but there is one little math trick that you don't often need, but you need it in this question. So I'm going to make a whole step out of this. I look at this and I see a negative x and a positive 2. And then I look down here and I see a positive x and a negative 2. It's the exact opposite signs. That is my hint that I could factor a negative out of the numerator, like a GCF. You can pull a negative out of everything. They don't both have to be negative to pull a negative out. And then when I do that, and again, you don't need to do that every single question, but you know you need something to match up, so something cancels. Now that something cancels, direct substitution should probably work out fine. I've got a negative 1 on top and a 3 times 3 on bottom, so negative 1/9. So I'm going a little bit faster the last couple steps because those aren't too different than what we've been doing, but the first step, taking it from a complex fraction to a not complex fraction. That's where I need your full attention on the next few questions. Okay, anything that jumps out at you about the first example before we try again? Okay, so different complex fraction, you should still start off with direct substitution. If you get a number, great. You might be done, but if you get 0 over 0, we've got to make this stuff look different. So again, mentally, I know you're going to get sick of me saying it, but mentally you need to go through how we've been laid this out to you for you the last few class periods. I don't have a graph like day 1 or a table. I can't factor this like day 2. There's no conjugates to be done. There's no trig equations to be done. The only other thing we've talked about now is complex fractions. So I would love to multiply this by 7 because times 7 divided by 7 cancels out. But that's only mathematically okay to do if you multiply everything by 7. It's all or none. I would love to multiply this one by x because times x divided by x cancels. But if I multiply that by x, everything has to be multiplied by x. Your complex fraction is going to get kind of messy. You need to be real careful with what you have left over. I've got a 1 times an x plus a 7 times a 1. And in the denominator, I have a 7 plus x that's been there, and a 7 that I multiplied it by, and an x that I multiplied it by. Multiplying everything by those smaller denominators takes it from being a complex fraction where there's small fractions within a big fraction to at least it's not a complex fraction anymore. This one appears to cancel pretty quickly because x plus 7 and 7 plus x are the same thing. The order of addition doesn't matter. Addition is called commutative, which means the order that you do those don't matter. And now that something's canceled, I should just be able to plug into what's left over, and it shouldn't be an indeterminate form anymore. So again, I'm not too concerned about the second half of the question. I know you still need to practice that. There's no such thing as too much practice with that, but I'm really more focused about the first step. You need to see why I wanted to multiply everything by 7 to get rid of this, and why I multiplied everything by x to get rid of that. Goes from a complex fraction to at least it's not a complex fraction. You might be almost done. You might still need to do a couple steps, but getting it out of complex fraction mode is what we're aiming for here. Okay, so let's look at one more as notes, and then I'll have you try the next one as guided practice to help you identify where you might not be understanding. Okay, so direct substitution, 0, 0, this is indeterminate form. None of the other stuff we talked about would work on this question. It's a complex fraction. This is h approaches 0. So I would love to multiply this by 3 so that those cancel. So multiply everything by 3. I would love to multiply this by h plus 3 so that those cancel, which means I have to multiply everything by h plus 3. If you're not making your work as nice and neat and is using as much space as you can, it's going to get pretty messy pretty quick. But with these two canceling, I'm left with this stuff, and I'm just going to go ahead and FOIL it out. Oh no, that's not FOIL. This isn't an exponent. This was times 3. Should be more clear. But that would be like 3h plus 6. So I'm just guessing that I probably need to distribute that. Over here, I've got negative 2 times h plus 3. So that would be negative 2h and a minus 6. Make sure that you don't treat this as a positive 2. You have to treat it as a negative 2 because of this minus. And in the denominator, nothing canceled. So I have the 3, the h, and the h plus 3. So again, it looks like I'm doing a lot, but I really just multiplied everything by 3 to get rid of one of the smaller fractions, and then multiplied everything by h plus 3 to get rid of the other smaller fraction. Okay, now I can see these two could combine like terms. These two can combine like terms. Something cancels, so we are probably about to be done. Plug in 0 to everywhere there was an h, and you're left with 3 times 3 in your denominator, 1/9. Do y'all remember working with or simplifying complex fractions at all in Algebra 2? A little bit? Okay. Usually y'all see them some, but not maybe as much as you really should. Complex fractions are a little bit important in calculus, but very important in college algebra, so still good practice. Okay, finish copying down what you need to there, and then I'd like you to try question 6 to see if you can finish it or at least see where you're getting stuck. So let me give you a couple minutes to try 6, and then we'll go over it to help you get over that hump. I'm giving you a few minutes to actually try to finish the question. So. need to do this for this question because I'm going to go over it in a minute. But like the other limit questions and how I've been suggesting that you check a couple of them by graphing, you could graph that mess in question 6 if you had a calculator, and then just go from a graphing approach from there. Again, on your test, some of it will be no calculator, if not all of it. So you can't use that as a way to get your answer every time, but you might be able to do that to check some. Okay, one more minute, and then we're gonna go over it finished or not. Okay, so the most important part to me here is the first part of this, because there's only a limited number of these question types that I have available for you guys to practice. So this did give 0 over 0. All this went to 0. All this went to 0. So that's why we had to do a little bit more work here. Okay, so you should have multiplied everything by 4 to make this denominator go away, and you should have multiplied everything by x squared to make that denominator go away. And do that clean enough that you can see that what was left over was a 3 minus 3x squared on top, and a 4x squared x minus 2 on bottom. That's the new piece of how to deal with the complex fraction. Again, it's not finished, but if you can get to that part, then you at least don't need to worry about the complex fraction part of it. Okay.
I have a question.
Yeah.
Where did the 4 go? Were you supposed to multiply that 3 by the 4, or where does that go?
Oh, I should have, yes, thank you. I multiplied everything by x squared, and for some reason I only multiplied 2 of them by 4. So this should actually be 12. Thank you. Now, as much as you may not like these questions because they do take a little bit more work, and one minor mistake early in the problem can, make you waste a few minutes. But one nice thing is usually if you make a mistake like that, a few steps later, you're just never going to get anything to cancel what you know they're supposed to cancel, so you know something's off. Okay, the rest of this is stuff that you guys need to continue to get better at, but we have been practicing some. So I look at this, and I would factor out a 3 as a GCF, and what's left behind is the difference of 2 squares. So I don't know that it needs to be completely factored, but most of the time you factor, you want to completely factor. Okay, and then it looks like you needed to do the factoring out a -1 trick to finish this question. Looking at these two that I'll highlight, they're almost the same, but they have the exact opposite signs. +2, -x, +x, -2. So if I factor a negative out of one of them, either one, I can switch those two signs, because if I distributed it, it goes back to what it was. Then something can cancel, and now that something is canceled, direct substitution should probably finish up fine. -3 times 4 over 4 times 4 So negative 3/4. Yeah.
Why couldn't you just cancel the x squareds?
These x squareds?
Yes.
That's a good question. So in a fraction, when you have terms are things being added or subtracted, you can't just cancel these out. You can't cancel out terms, you can cancel out factors. Factors are things that are being multiplied. If I split this fraction apart, like if I put 12 over this, oops, I think it might be a little easier to see why that's problematic. Minus this over this. If you do that, then sure, you can cancel these out. The problem is that 12 doesn't have an x squared to cancel out. So by canceling out this x squared up here, you're pretending like it just wasn't there in the first place, and that's a problem there. The other, if I just, and I know that's a very large temptation, but let's say if I did like, let's just do like this with basic numbers. The real answer to this question would be 7/3. That's correct. But if I let myself cancel out terms, like this 3 with this 3, which is what you're trying to do with terms, you're going to think that the answer is 4, which is wildly different, and that doesn't make sense. So things that are being multiplied, like factors, can be canceled. Things being added or subtracted, like terms, you cannot cancel in a fraction. Okay, other questions about that one? Okay, then let's do the last one together, except I would like you to at least try the first step. So write down what you think you would need to do to make that not be a complex fraction, and then we can finish it up as notes. You don't have to practice the whole question. I just want you to practice the first part, since that's really the only new thing. Okay, so of course you should try direct substitution to make sure it's 0 over 0. But other than that, you should have realized you needed to multiply everything by 9 to make those cancel. And you should have multiplied everything by 3 plus x all squared to make those cancel. If you can see why we're doing that, then you can deal with any complex fraction. Okay, to finish the question for your notes though, since these canceled, we're left with 9 times 1. Since those canceled, we're left with negative 1 times this stuff. I already put the negative down. So. And in the denominator, we've had the x that have been there, the 9 that we multiplied it by, and the 3 plus x all being squared that we multiplied by. Okay, to practice finishing this one, we know that something has to cancel. So the thing we just talked about, I know this is very tempting to cancel these two. They look the same, but this guy is a term. He's being added or subtracted to something. This guy's fine. He's a factor. He's being multiplied, but you can't cancel these yet. So to be honest, I haven't worked this one since last year, but my guess would be we should probably FOIL this stuff and distribute the negative. So that would be a 9, this would be 6x, so distribute the negative, and an x squared, distribute the negative. And the denominator is already factors, so I probably don't want to do anything with it if I don't have to. We'll see. Combining like terms, those go to 0. I see that we could factor out a GCF of, I don't know, at least an x. And then something cancels. I'm suspicious that maybe we should get more to cancel, but since something is canceled, I'm going to hope that I'm not in indeterminate form anymore. If I plug this in and I still get 0 over 0, then I got to do more work. But if I plug it in and it's not 0 over 0, I can assume that's my answer. So plugging in 0 gives me -6 on top. That's a great sign because that means I'm not going to have to do anything else complicated. And then plugging in 0 down here leaves me 3 squared, which is 9, which reduces. So once again, I'm not saying the last couple steps are easy, but you've been practicing the GCF, combining like terms, getting something to cancel, and finish with direct substitution for 3 days now, or 3 class periods now. So knowing how to fix that complex fraction though may be unique to you. Okay, I think this is the last complex fraction I'm asking you to look at today. So this would be your last chance to speak up and tell me if there's a part of that you'd like me to explain more or ask something specific about.
The last one, shouldn't you also like the 9 multiplied by 9? That's
Yeah, I don't know why I didn't do that. When I plugged in 0 down here, I got 3 plus 0 squared, which is 9. This is where I'm as guilty as, I may be more guilty than you guys, but this would be -6 over 81, which actually reduces to, I think, -2/27. If you do not make your work as easy to follow as possible, you can see how easy it is to just forget that number there. I didn't do anything wrong mathematically until the end, and it was just being careless. But yes, thank you. And that's a lot easier to do if you're not spacing your work out and trying to make your work look very legible. I know a lot of you guys have really nice handwriting, so you don't have to worry about that, but some of us don't, and these questions can be hard enough as is. Okay, the other thing I'd like to practice today is doing limits from piecewise functions. So a big part of calculus that struggles students is you guys have seen piecewise functions, but not real comfortable with reading piecewise functions. So we're going to kind of tap into what we did on day 1, talking about left and right limits. And then we're going to use this piecewise function and talk about how to read it, when to use the top part versus the bottom part. Some questions we need to use both, some questions we'll just need one. But make sure you're giving me your full attention here too, because these questions can go pretty quickly. So, at least for this first one, you should probably write out, to answer this, since this is as x approaches 4, not from the left and not from the right, we need to figure out what the limit of 4 is from the left, and what the limit is as it approaches 4 from the right. If these two numbers are the same, that's the answer to our question. If they're different, the answer to this is does not exist. Same thing we did on day 1, we just don't have a graph, we have a function instead. So if I want to plug in as x approaches 4 from the left, you think about on the number line, to the left of 4, the number is going to be slightly smaller than 4. So that needs to be plugged into this one, because it's saying when x is less than or equal to 4. I don't care about the equal to. But if you're approaching from the left, x is less than 4. So we should be plugging that number 4 into this. And 2 to the 4 is 16. But from the right, you think about on a number line, if you're coming from the right side of 4, it's going to be when x is a little bit bigger than 4, which is the bottom part of this piecewise function, because it's saying use it when x is bigger than 4. So you plug in 4 into that. We get 8 times 2, which is 16. And again, you don't need to write this out every single time, but I do think it's a mistake if you don't write it down at least once. That's what has to go through your head. What does it approach on the left? What does it approach on the right? If it needs it to be both, like this question, your answer is either 16 if they're both 16, or it does not exist if those don't match up. Now, don't fall into the trap of saying, oh, okay, I know what to do now. I'm just going to plug it into the top, get a number, plug it into the bottom, get the number, and then that's my answer. That's not going to be true every single question. Not every piecewise function is going to be the same. So, in number 9, we want to know as x approaches pi. So, to me, I guess this one is kind of the same. So, I should think about the limit as x approaches pi from the left. And mentally, I need to be thinking about x approaches pi from the right. So from the left is when x is less than pi, which would be this one. When x is less than pi. Remember, alligator eats the bigger side with the inequalities. So we're going to plug pi into this, and the cosine of pi is -1. But pi from the right, from the right side of pi, you're going to need x to be a little bit bigger than pi. So x has to be larger than pi. And so for that part, we need to plug it in to this function. And the sine of pi is 0. So if the question had said from the left only, our answer would be -1. If the question had said from the right only, our answer would be 0. But this appears to be neither one of those, which implies both. If it's approaching a different number on the left and the right, that's how we know the limit doesn't exist. It's not approaching a consistent y value from both sides. Okay, I think 10 looks kind of similar to the last two that we've done, so I would like you to try this one. Think about which one you would plug in for the left limit, which one would you plug it into for the right limit, and then based on those two numbers, see if you know what your answer should be. So hopefully you're starting to see with this question, you have to know a few things, but honestly, once you figure out what you're supposed to be doing, they're not super long questions. I'm not going to write out all the work again on this question, but mentally, I'm thinking about the left limit. So that would be as x approaches -2 from the left, which is where x is smaller than -2. Plug that into the function. 5 times -2 is -10. And from the right, I would need x to be a little bit bigger than -2, which is what this is saying. So plugging -2 into that also gives -10. It's approaching -10 on both sides, so that should have been your answer. All right, but depending on what the numbers are, sometimes you still only need to plug it into one or the other. So I think you need to go over to the other handout now. Is that correct? That's just these type of questions. So let me look real quick. Okay, I'd like to do 3 more questions as guided practice, and then I will let you work the rest of these at your own pace. So on this second handout, again, I know some of these don't print out the best. So go down to question 3. This one only wants to know the limit as x approaches -1 from the left. If that didn't print well, squeeze it in there. I'm going to ask you to try that one. Number 4 wants to know from the left only. Please try that one. I don't know if this one printed off well. Again, sometimes my copy looks fine and y'all's are copies of my copies, which makes it look off. But question 5 wants -4 from the right. So squeeze that in if it doesn't show well. And I'd like you to try question 2. So try 2, 3, and 4. To see if you can adjust to the differences on those questions and what we did on the other 3. Again, shouldn't be too, like none of these questions should be taken like 5 minutes each. So try what you think you should try, and we'll make corrections if we need to. Bless you. Okay, that should have been about time to work each one 3 times. So that should kind of show you wherever you were slowing down is your indicator of what you need to highlight, and maybe make a quick little note to yourself or something so you remember what to do. All right, number 2 is a little bit different because, again, if you just train yourself to say, okay, well, the first 4 questions we did, you just plug it into the top one, plug it into the bottom one. If the numbers are the same, that's your answer. That's true sometimes, and sometimes it's not. This question wants to know the limit as x approaches -3. Which one of these did you try to plug it into? The top or the bottom? It should not go into both. You should only plug it into the bottom when you want x values between -2 and 1. -3 is outside of that. In this question, that bottom part was just a distractor. For this question, you should have only plugged it into the top one because it always gets used when x is less than -2. So whether you're doing the left limit and plugging it in here or the right limit and plugging it in here, if you're plugging the same number into the same thing, you're going to get the same answer. Should have gotten -5. But the bottom is not appropriate because the bottom was only to be used if you need an x value between -2 and 1, which -3 is not. It does not fit that. You don't need both parts. Sometimes you just need one part. You gotta be careful with these restrictions to know which one to use. Okay, question 3. This one wanted the limit just from the left. So once again, you have to think about what these things mean to know which one is going into. This one is saying when x is less than -1, which is what's happening if you're coming from the left. So you should have plugged in -1 into this, and you could say e to the -1 if you want, or you could change that to 1 over e if you did exponent rules. Either one of those is fine. But since it was from the left, the only one that makes sense is the top part of that inequality. The bottom is when x is bigger than -1. That would be if you cared about the right side. This question I didn't care about the right side because it specifically said from the left side. Okay, and then same thing with question 4. If all I care about is from the left side, I need to plug it in to the one that has the number slightly less than 3, which would be this one. And your answer should have been 8. Again, if you can read a piecewise function, it's not like you're doing 6 steps per question like sometimes we have to do. So that part's nice. But you have to be very careful that you're using the right part of the inequality or both parts of the inequality, or it just depends per question. It's not formulaic enough where I can say just always do this or always do that. You have to actually read the piecewise function. And I can tell you the first few weeks of calculus, that is a big hurdle for students if you don't solidify that. So, okay, so what I'd like you guys to do to finish up class here, we've got about 45 minutes. So looks like you've got 2 more questions on the front and 1, 2, 3, 5 more of these on the back. So if you would, please try those to see what you get, and maybe compare with your neighbors to see that you're getting the same thing. And of course I can help you if you're getting 2 different answers and you're not sure which is which. That'll finish up the new thing I want you to consider today. And then to totally finish class / homework if need be, I assigned only 1 Khan Academy assignment. It was over one of the question types we did last class, which was indeterminate form with conjugates. So you might want to look at handouts 69 and 70 to review yourself how we did that. And again, those questions are a little bit longer, so you want to work those out carefully so that you can not have to restart a bunch of times. But it is definitely a skill I need you to get more practice on. I don't think I have an answer key for this, so I am going to finish working this out and scan it and put it on the website, but it's not up just yet. But in the meantime, you guys can compare with the people around you. If you're all getting the same thing, then hopefully that means you're all getting it correctly. So. For which one? Question 1. Well, I don't think you should need a calculator. Are you trying to use a calculator to check your work, or do you think you need it to get your answer? The fact that you plug in -5 into sine of x pi. Okay, well, since that's a pi and it doesn't say degrees, that implies radians. So if you want to type that in your calculator, you need to be in radians. But the cosine, I'm sorry, not cosine, question 1. The sine of -5 pi, that's still just a unit circle spot. Here's -1 pi, -2 pi, -3, -4, -5 pi. Sine would be 0 there. So you shouldn't need a calculator for that part. It's a kind of an unusual angle, but it does land on the unit circle, so unit circle still applies. Yeah.
Well, if it doesn't say anything, then you have to do both. And if it's saying, that's
I think remember on the last page, you made it try because we couldn't see them.
yeah, I know, but on these ones, if there's like nothing there, then you just do both. So I think,
Like, remember how we had to write these in? Like, we could,
yeah, oh
did you write those in?
yeah.
Yeah, so we couldn't see them. So we didn't know, we did both of those.
I told you all the ones that were hard to see. 3, 4, and 5 should have been the only ones that were hard to see. The rest,
So on the back, there's no from the left and from the right.
right, it's both on all of those. So you got to do left and right and make sure it's the same number. If it's not the same, does not exist. If it is the same number, that's your answer. But that doesn't necessarily mean you plug it into both parts of the piecewise function. You might still only plug it into one part. Like question number 2, it needed both, but I still only plugged it into the top both times.
Why is that? Because 5 wouldn't go into -2.
Number 2,
Yeah, it's not between negative. Yeah, it wouldn't go into.
yeah, if you want to know as x approaches -3, this has nothing to do with -3. So that's how I know this is irrelevant to that question. This function is always when x is less than -2, which would be slightly to the left of -3 and slightly to the right of -3. So you're just plugging it into both of those. But if you're plugging the same number into the same function, you're going to get the same number. So
6 times.
For coasting.
So it's coast. Okay. picked up the first time.
Okay, I finished those, so give me a second to get that scanned in, and I will add it to my website.
No, so you go, one is here, 2, 3.
That way you're welcome to check.
Okay, so it's basically 0, 0.
And what you want, because it's on the right side, so cosine's the x.
Pi, so 1, 2, 3, 4, 5, 6.
Yeah,
So that's
1, 0.
yeah, there's 1, 0.
Cos is 1.
So that'd be the that. That's good. Next one.
And then, so would this one not work? Because it's not greater than negative 3.
Negative 3 is not greater than 1.
Yeah, so you would just do the first one twice. So you get the same thing, so it'd be 2.
Yeah. This is by far. This is killing me. Then for the next one. So, yeah, greater than or equal to, less than or equal to, so I have to have both in row. So negative 2. That works. No, they're both negative 10 for this one. On 8. 5x, 5 times negative 2 is negative 10. Negative 2 cubed is negative 8, minus 2 is negative 10. Well, it was, because it would work, because it's less than or equal to negative 2.
On the 8?
Yeah. For the bottom one, it's less than or equal
Yeah,
to.
on the top one though, it's negative 2 is less than negative 2.
Same. Less than negative 2 is greater than negative 2.
I'm talking about the top part, right? This part here.
Yeah.
So if you plugged in negative 2, it'd say negative 2 is less than negative 2.
Yeah.
So that would be right. So that would be right.
See, like, look for number 2. The top one, it says negative. Oh, it's negative 3 now.
On the bottom, number 5, it said negative 4.
It's greater than negative 4, and we still did that.
I didn't do that
Well, I didn't do that one either, no. I just did the top one. You got 1/3 on that one?
Yeah.
Or negative 1/3. Well, maybe I guess you don't do that.
Doesn't make sense.
What else?
I'm trying to learn this.
I know, I'm also trying to learn that.
You can come over here. So I guess you don't do that. So I guess you just, the top would still be, yeah, still be negative 10. So I wouldn't wrong, but it just wouldn't be wrong. Yeah. So there's negative 1, so I guess you wouldn't do the top one for 9. Right?
But they do all this.
That's what I'm saying. I don't know. That's what makes me think it's not right.
So for stuff like this, like negative 1, would this not work because negative 1 isn't less than negative 1?
Well, it's saying use this when you want x values less than negative 1. So if you're thinking about the left limit,
It's coming from
you should be using that because from the
Yeah.
left it is slightly less than 2. So in that question, you're plugging at the top for the left limit, and then the bottom for the right. You need to make sure they're the same.
Oh, it's supposed to be 1.
So 8 is fine. 8 is 8, right? So I guess it's not a range. This is just saying for when x is greater than negative 3.
So this one only didn't work because it took this part.
Yeah, because if only these are ranges, these is just like telling you like from x is greater than negative 3, which is going to be from the right. So 6 6 is still 6. Still 6 is still 2 times 6. 7.
I don't think that one exists either.
7. So -3. So 2 at the bottom, and then -3. Yeah, then it'd be 4.
Yeah, 4. I got 4 and 2.
That's not existing. And then 8's fine. 9. So it's got -1 on top. That's -1 on the bottom too. I got -1, -1.
Okay, I just uploaded my answers to this extra practice to the website, so you'll have to refresh that page if you already had it pulled up, but make sure that you understand where those numbers are coming from. Again, we try not to give you too much information any given day, but if you're falling a little bit more behind each day, you're going to be overwhelmed by the next test. Okay, if you need any help with that, let me know. And then, of course, as you finish that,
So sine of x.
please try to do the One Khan Academy. I don't intend for that to be a lot of homework, but you need to work on it in class for that to be the case. And then if you don't have 7D in Google Classroom yet,
Okay, my bad.
make sure you do that before next class. All of that's written out on the board.
Sine of pi is 0, and then pi over pi is 1. 1 minus 1 is 0. So it's 0. Alright, I guess I wasn't terrible. I got confused with that. Yeah.
Is there any papers that I missed on Monday?
There is. You're going to need to watch the class recording to see what you missed.
Okay.
Well, the class recording is going to show the agenda and it's going to tell you which papers you need to get. But they should be in that binder over there.
Okay.
I just don't know the numbers by heart. All right, again, you guys have about 30 minutes here to try to limit how much homework you may have. So let me know if there's any of that I can help you with. I'm not going to keep bugging you about it, but if you need help, this is your chance. And for this Khan Academy, you will definitely need some scratch paper. So please number your scratch paper as number 73. Since you got to make the scratch paper anyway, you might as well number it because that's the number that's going to be in the grade book. So.
Is this 72?
Yeah, both of these are 72.
Got here early for that?
What is 70? Oh, there's the
Well, I saw it fucking out in your I mean, there's another cow in his room.
Oh, I haven't really seen that. Okay. Front and back of this, 70.
I think these are notes.
Oh, so the back is 70. That makes sense. You want scratch paper? Yeah. Please, thank you. Appreciate that. This is 73.
thing that might be smart on the Khan Academy is to check your answers by graphing before you submit your answer. That way, if it's wrong, you don't have to start over. You might be able to just correct your mistake before you submit your answer and get it done in one go instead of multiple tries.
I have a question on one of the questions. I'll
Okay.
use this one. I checked the key and it says that this one's 4 and me and Luke were both kind of confused.
Number 7.
Yeah.
Okay.
Because we plugged this one into the bottom one because it's like if X is like if you're coming from the right it'll be greater than
Okay.
-3 and we got 4 and then if it's
Okay.
coming from the left it'll be less than -3 and we got 2. And maybe I just kind of want you to look at it because I may have my math wrong.
No, you're right. I just, when I plugged it in, I just did too quick. I saw
Okay.
7 minus 3 was 4, and I didn't think about the square root.
Okay.
Yep, you're right.
Okay. Thank you. That's all I was wondering.
Sorry, I have one mistake on the key, on number 7 on the key I need to fix. I will re-upload it in just a second.
He gave this to us 2 days before the test, and we have to memorize all of this.
Number 7 on the worksheet, it does not exist. Not 4. I made a mistake.
This is 69. Is there a spot to start at 69? No. You guys want to do it? I just kind of look at it.
Yeah, you can look at it.
Oh, 69 and 70.
Yeah.
I just have to look it on my phone instead of just
So which one's 67? That's the one from last one. One of the same questions that I got on 7.
Do I?
I got one of the same questions that I got on 7.
You have to get 4 in a row, right? No, well, come again, or then again.
Yeah. Well, I would like to keep that speed just
Oh, yeah, that's right, it does, yeah, but. Sweet, thank you.
just plug it in.
Is this one from last class, right? From Monday?
Correct. It's just the back page of that.
On the key says it.
Yeah, that's the one I just had to fix.
Okay.
I just now fixed it on there.
Okay.
Yeah, guys, on this practice worksheet, if you didn't hear me a minute ago, I had a mistake on number 7. I fixed it, re-uploaded it on the website, but unless you refresh the website and re-download the solutions, it's not going to show. It should be does not. I had said 4 because I was too sloppy with my arithmetic. It's supposed to be does not exist. But again, it should be correct on the website now, but you would have to refresh and re-download the solutions.
You doing the conjugate sum? So that's going to be multiplied by the radicals. If you give wrong, you're completely reasonably scared. So, yeah, you're welcome, yeah. Yes. 5 plus, and then it'll be time, that'll be minus 25 when you do it, when you're done with it. So on the numerator, it'll be 25 minus, that'll be 3x. So 3 minus 5.
Okay, you guys are down to about 5 minutes here. So, if you did not get 70 turned in the Google Classroom, and or you did not finish getting 100% on the One Khan Academy, you need to do that before I see you on Friday. Again, the Khan Academy is a little bit longer, but there is like 10 people that have already finished it, so it's not that long, but it's longer than the 2 I gave you last time.
So I can find that there, and then I got 3. It would be negative 1x plus. So like, yeah, so I can find mine too. And then so it'd be 28 minus 3x. So where it'd be 3 minus 3x. And then you take up 3, it would be x minus 1 plus, like, take out negative 3. Yeah, 3 plus 1. 25. Where you get 53 from? It's going to be a negative 25, not a positive. Yeah, because a negative 5 times 5 is going to be negative 25. Because you're going to multiply the positive by the negative. This is a negative. If you're going to multiply by the negative. Oh, wait. Yeah, because that's a positive. So, yeah. So, just
I'm kind of confused.
yeah.
And the ones where the 16 things right here.
Okay. Well, when you FOIL these numerators, 5 times 5 is 25. Square root of 3x plus 28 times square root of 3x plus 28 is going to be 3x plus 28. But you see how one's positive and one's negative? That means the whole 3x plus 28 is negative. And the way you have it written, you only have the 3x in it. So you got to put parentheses or just distribute it right away. Because the whole thing is negative, not just the first part of it.
I got all right, but figure it out.
So what I did was, I was like thinking about